And so again, welcome to today's webinar on mechanical system design considerations. This is going to be that overview look at the mechanical design, really as the introduction to what we'll be talking about later in a few weeks when we come back and talk about mechanical plan review, where we'll actually break out a set of plans or a series of plans and really evaluate them for mechanical compliance. But this is more of that technical review, and so just keep that in mind as we go through some of this. So this will be great notes and things. And maybe if you have questions, feel free to throw them in the, I'm going to make sure I pop up the Q&A before I say that. So, okay, I've got the Q&A open. I've got the chat open. If you have questions that we need to talk about verbally, raise your hand. We can always unmute you. But again, we want to have this conversation about some of these different things. So for those who may not remember, we're the Minnesota Energy Code Support Program is here to provide. It's a program created by the utilities in the state to provide education support and resources to you as building officials and building professionals, whether that's design or installers. So if you do have those individuals in your community that aren't currently aware of our programs, feel free to invite them. And then we offer those again free of charge. So we are doing our monthly, we have a monthly in-person webinar, our in-person training. And I think we may be even expanding sooner than later our webinar series to every week, just to provide, again, another opportunities for more in-depth, series on inspections or plan review, just to kind of, again, provide all the resources we can. If you have any questions, you can always check our website out, Minnesota Energy Code Support.org. And if you have any questions, again, feel free to reach out to me. So we talk about this every time that I do a training, that it's most important that we understand the why we're here so that we can figure out the how. And again, that's a critical part of understanding mechanical systems, because if you don't understand why we have mechanical systems and what the calculations are behind them, then it makes it very difficult for us to understand or to ensure that they operate effectively. So the code as a whole exists to really provide us that basic uniform standard for buildings that are built throughout the state, so that we have a clear or consistent understanding of how buildings should be built. It's a conversation that I have quite often on a variety of different communities when it comes to, especially with some of the older builders or maybe builders who've been around for several decades at least, who come in and will tell me. I literally had this conversation at the football field last Friday, with a builder that says, I don't understand why we keep changing the codes. It doesn't change anything. I've been building the same way, for 20 years. And I told him, his name was Thomas. I said, Thomas, do you think that the materials you're using today are the same they were 20 years ago? Are you using the same shingles? You're using the same 2x4s? Well, no, we're using different. Well, so then the systems and different installation expectations associated with those change over time. And that's really what the state and code development as a whole is looking to provide. What's that basic understanding of construction in our community? So again, the digression that we don't have time for today. But again, I think if you're not already a part or participating in some of those technical advisory committees, of those tags that are ongoing, I know I've got one scheduled for next week on mechanical on Monday. Please make sure that you're participating and you're getting involved in some of those, at least paying attention to them and the conversations that are going on, so that again you're aware of the conversations that create and drive the adoptions that we see throughout Minnesota. When we think about the energy code as one of those components, one of those state adopted codes, the purpose or the why for an energy code is all about, again, ensuring that a building is effective at mitigating or controlling, right? Control is the big name. Controlling heat loss, controlling energy consumption, right? So that the individual who owns and manages or resides, occupies in that building is able to have a clear expectation of how that system is going to operate, right? How this building is going to operate as a whole over its useful life. And when we really start talking about mechanical systems, we understand the mechanical systems are one of those critical components on how effectively a building is going to operate. And when we talk, and we'll see how in some of that context, building thermal envelope components and building design and planning is really important to understanding how that building is going to operate over its useful life and what kind of equipment we're looking at. Now, as far as a code, the energy code addresses all varieties of stages of construction, right? From new buildings to additions to new systems, replacements, new equipment, alterations, changes of occupancy that affect how a building is being used. All of those systems, all those operations have to be reviewed with a mindset or an eye towards energy conservation, energy efficiency, right? Even when we talk about certain types of historic buildings, we really, yes. Ahmed, the question is whether or not you get credit for this webinar to renew. So yes, this course has been certified for Minnesota DLI as well as AIA for architects and ICC for those who still maintain ICC certifications. So it's been certified for 1 hour building officials within the state, and then it's just the normal 1 hour health and safety in AIA and the others. So, but what we're looking at is, again, even in historic buildings, we have a moment when we provide clarity, or we can use the code to address how a building is designed, right? We're still thinking, even in historic buildings, there are elements of this that we would find or that would control how we do some of these remodels and modifications, alterations to those types of buildings. When we look at the code as a whole, we see that the code is broken into, as we think about the ASHRAE standard as the base. It provides us some mandatory, prescriptive, and alternative compliance sections within each chapter. But what we're really looking at is these four main concepts when we look at how buildings operate. We're looking at a building's thermal envelope, its mechanical systems, its service hot water, and its power and lighting calculations. And so today we're really going to talk about those two ideas of mechanical systems and the relationship with surface water heating. And so now it looks like my camera has messed up a little, but hopefully you can still hear me. So somebody give me a thumbs up, you can still hear me. You don't need to see me as long as you can hear me. Am I still there? Okay. Woo! Scared me there. Scared me, Dean. I'm just telling you. So you don't need to see me as long as you can hear me. But so when we think about design, right, when we think about mechanical systems and the considerations that kind of play into how a building is going to operate, we think about design calculations, right? We think about distribution details. We're going to look a little bit about how equipment efficiency is evaluated, and then those system controls. Now, very, very briefly, remember, in all of these different types of buildings that we talked about in the previous slide, whether that's new buildings, alterations, changes of occupancy, all those situations, we're provided three different paths for compliance, right? Prescriptive, which is the methodology where we say, tell me what to do and I'll do it, right? The second path is going to be our energy cost budget analysis. And then the third will be that performance rating. So again, prescriptive is that tell me what the book says, I'll do the book. Give me a table, I'll do it. When we think about energy costs, that's going to be looking at, again, systems that employ some type of mechanical, right? That's going to calculate the cost, the financial dollars and cents cost to operate a building over the course of a year, an annual energy cost calculation. And then it's going to require us to compare that annualized energy cost against a reference design of similar size and that meets the minimum expectations of the code. So that provides you that flexibility. As long as this building is going to efficiently, is going to demonstrate the same level of efficiency as the minimum expectation, that you can allow for flexibility in that design, right? It's very similar to what we find in Appendix G, which is going to be that performance compliance path, that performance-based compliance path. However, we're not looking at dollars and cents. We're looking at other calculations that evaluate the performance of that building. And a lot of times that's based on which software you're using as to what measures you're using. But as long as you have that performance calculation, then again, you're looking at how these buildings are going to perform, right? Very quickly, remember there are some amendments that the state incorporated to the ASHRAE 90.1 standard in the 24 adoption, and I've just outlined them here for us so that again we understand these are the ones that apply to mechanical systems. At first, we'll run through these very quickly. The state added, for those who may not already be aware, the state added a subsection just reminding us that when we have rooftop mounted HVAC equipment that it has to be installed so that in the appropriate insulated curbs can be incorporated in its installation or replacement, right? There are certain expectations on the thickness and the requirement for insulation in rooftops and rooftop mounted units. And so we want to make sure that future equipment is going to incorporate the appropriate spacing, right? Very simple. We'll run through these. The other alternative is just to remind us that if we're having heating of enclosed, a new section that identifies that enclosed commercial parking facilities, heating is prohibited in accordance with the statutes that exist, except for when there's certain types of examples that are provided there. Sorry, I'm reading through. So again, there's a new section on prohibitions regarding once through water use permits. There's also a section on that reminds us that the climate map was amended. We'll show you that here in a minute. I tried to put them on one at a time, and apparently I did one section per slide. Again, it provides us it modifies the exception when we talk about ventilated systems to have automatic or non-motorized dampers, right? When we're talking about certain size, different outdoor air intakes. We deleted an item from section 6.4412. We'll talk about that when we get to it. Modified the size, the expectation of size of conditioned floor areas and non-transient dwelling units. Also, we included modified the table and allowed for the table for when we have to have fan systems in non-transient dwelling units, and modified that table. It was deleted and replacing is ambulance parking considered as commercial parking. And so I think if we were to go back to that one, I would have to double check that one, Andrew, Artie. But I think that in that situation, at least in most of the ambulances that I'm aware of, they're not heating the space; they're heating the equipment, right? So they have generally there's some kind of a unit plugged in. My best friend is a firefighter and fire chief, and so it's usually keeping the vehicle warm, not the space around the vehicle. But that's a great question to look into or to discuss. When it comes to that, I don't see that clearly defined or related there. One of the things that the code also does is some of the amendments that take place is just a modification of those required duct insulation values. So again, that has been deleted, replaced. Again, you'll get a copy of all of these handouts when we're done, so that you can feel free to read over anything that we don't hit in detail. Also, when we talk about alterations to existing structures, again, that we're talking about new piping, new alterations, they have to comply with the requirements, the mandatory requirements of the code. We talk about water heating facilities. We'll get into those a little bit more. We talk about when we get more than 50% of our annual energy from renewable or site solar, site recovered energy, then we're allowed to have buildings with high capacity heat pump systems. But more importantly, when we think about how a mechanical system is going to be designed, we really need to start with an understanding of where it is in the state, right? While a lot of things are similar across the state, I have made it a personal, not goal, that's probably the wrong term, but we recognize that there are two distinct climate zones in the state. And so when you can see that area that's highlighted or a little bit misshapen, where the state modified and extended climate zone 6 into this section of what was going to be recognized as climate zone 7. And so we need to understand that the design that's associated, more importantly, with our building takes into account the appropriate design calculations, right? We want to make sure that this is designed for Minnesota, for Bemidji, and not for Denver, Colorado, right? There's going to be certain calculations that go into that. That we also recognize and label our conditioned space categories, right? If we were looking at this from, again, an example of this example on the screen is a convenience store that we've talked about before in the past. I need to know what is going to be incorporated in that conditioned space versus what's going to be semi-heated or non-conditioned, right? We need to know those and have those identified on the floor plans so that when we evaluate that building, we're again making sure that we calculate all of that in our mechanical calculation. I was in a program or a conversation with somebody yesterday, a class, where we talked about, the impact of radiative heat in non-conditions and traditionally semi-heated spaces, right? And so you can have, depending on the size and the design of that thermal envelope, you can have a lot of heat loss or heat migration from a conditioned space to a semi-heated space. And so that can influence the types of mechanical systems, the types of controls, the locations of those controls. And so making sure that we're aware of that when we think about what's going to be inspected, what's going to be reviewed, what's going to ultimately provide for successful installation or construction of buildings, we need to think about not only where is it going to be located, how is it going to be laid out. When we talk about what the code expects, remember the code expects us to provide these 18 different specified items on our documents, and the ones that are highlighted specifically are related to mechanical systems, right? We talk about the design criteria. We talk about the types, sizes, efficiencies of the different equipment. We talk about controls. We talk about different duct locations, sizing, insulation, so that we're aware of all these features when we review a project. And again, this is that groundwork that we'll have to where when we come back and look at plans. Now, one of the things that I always have this conversation, or seem to always have this conversation, and I recently had it with the ICC on this point, was our charge, and I was in a standard development committee yesterday, is our charge is to provide as much code compliance as possible. And nobody would ever claim to be 100% perfect, although that's the goal, right? We don't allow for substantial compliance with the code. It is reviewed for code compliance so that we expect you to comply with all the requirements of the code, not those sections that you think are important. I know there are a lot of people that prioritize different types of conditions within a building, and I am not that person. I think that you should comply with every section, and we can't say that just because I have an amazing thermal envelope, when it comes to my building, I don't need to worry about the mechanical system. I have such an amazing envelope, it doesn't matter what my mechanicals are designed for. I don't agree with that. I think we need to evaluate each piece of a building, and I don't think any of you would expect that someone would say, well, we can do close enough. The old adage you guys remember probably, or may have heard before, the close enough for government work. I always took great umbrage at that statement, because I take my job seriously when I was a building official, and so it's not close enough for government work. It's right or it's wrong, right? And so we need to be compliant as possible. The code provides us the level of flexibility that we shouldn't have to have those conversations about get the top 3 things, the top 10 things, and then don't worry about the rest, right? We have enough flexibility that we can make a building that is going to be energy efficient and provides for the mechanical ventilation and climate that we're looking for within, or comfort with inside that conditioned space, right? The code provides for us both a simplified approach to building compliance as well as our prescriptive compliance paths. Remember that and within that context, that it reminds us that when we're talking about new buildings or alterations, that we're looking for that equipment that provides the heating, cooling, ventilation, or refrigeration needs of that building, right? We're looking at not only, uh, we know that the simplified method applies in certain scenarios and in certain types of buildings that meet the specific size requirements and expectations. There's also a variety of different conditions that have to apply in that scenario. But what we're looking at is new buildings, any alterations, they're going to require compliance with the various different components that we see within the code, right? It can get very daunting. And again, this is going to be a very high level conversation. But as you start to identify the equipment, you're going to be able to refine your process, right? And again, I think it's in the beginning of October that we're going to look at mechanical plan review specifically and actually pull out some different systems, look at how they were calculated and how are they laid out in an actual series of different plans and specifications. So again, the 6.1 provides us that basic direction that these things are going to be complied. They're going to have to comply with it. Again, 6.1, again, additional expectations and exceptions associated with alterations. Here's that list of a very simplified list of some of the criteria that a project would have to meet to follow the simplified approach as an option for demonstrating compliance. And again, that's going to be a building that's two stories or less, 25,000 square feet or less, and that has a HVAC system that complies with all of the following, which is that it serves a single zone, right? There's a variety of 19 different notable criteria. Notably, we're looking for, again, single zone responsibility, that it meets the equipment and efficiency requirements, that is controlled with different, has different levels of control, whether we're looking at manual changeover, dual set point thermostats, right? That we have these basic understandings that are going to apply to every system. And we're just saying that in a simple world, you can have a simplified system. Now, we know there are buildings, if we think about maybe our example of a convenience store or a smaller office building that maybe houses the local real estate office or a regional building department, right? You're going to have a simplified system. That's going to be completely different from a 65,000 square foot, multi-use community center, right? Where we're going to have auditorium space and classroom space and community feeding areas. We're going to have a variety of different things. That's not going to be a simplified building. So again, we know that simplified buildings would have the ability, have that flexibility to follow this compliance path and those identified criteria. As mandatory expectations within the code, we're looking at three basic things, right? We're looking at equipment efficiency, calculation, and location, right? Efficiency of the equipment, which is where we're going to comply with tables 6.8 through 6.81 through 20. If it's a non-standard piece of equipment, it's going to have its own expectations for efficiencies. And then the calculations associated with those layouts. And then, like we said, we'll talk about a little bit about distribution, location, that kind of thing. So those are your main three concepts. Whenever you think about mechanical systems, you're going to think about efficiency, equipment itself, its calculation, its controls, and location. Again, if we're looking at a design, we're going to make sure, and we've had this conversation with a variety of different building officials and different practitioners, some different mechanical in groups within the state already. We need to make sure that the equipment calculation is being ran for the appropriate elevation, right? The appropriate heating climates. If I was a company, and again, I work with several different friends and architects in different areas. If we think about a Buc-ee's or a Sheetz or a Wawa, a gas station, a convenience store that moves into an area, sometimes it happens where maybe the design is just a copy of another location. And so you got to make sure that when they calculated the elevation, they made it correct, right? This calculation here is for Southern Colorado. That is not going to be consistent with what we need in any section, even if we said it was a climate zone 6, even if we were going to put it in Monticello, that's the wrong elevation. Elevation affects how equipment is going to operate and how the different expectations and calculations that we see with it, right? And so we got to make sure it has the appropriate elevation identified. We have to identify that, make sure that our calculation, and I know sometimes it's difficult as a building official or as a plans examiner to sometimes say, I need all these calculations, and they give you everything. What you want to make sure is that, again, it demonstrates that they've incorporated the appropriate amount of glazing, right? Are we going to have the appropriate calculations? Do those calculations refer back to the appropriate solar heat gains and overhangs and projection factors associated with the fenestration? Because we know we can talk about it till we're blue in the face, that with the sun is facing, we're getting radiative heat from that sun, and we don't properly calculate the impact of the sun into our office spaces, then we may have times when we have greater heat, greater radiative heat in an office space versus what was designed for. And again, elevation, orientation, these types of things really do start to have an impact. When we think about, again, I just did a class, it was a 2-week class, refresher for myself on mechanical design. And again, it was all about identifying the appropriate values. You know, what are we getting for the insulation associated with walls? What are we getting for roofing materials? Or the solar reflectance associated with those roofing materials, right? Calculating, you know, the types of lights. Now, most people are now going to LEDs, but if you still have organizations and entities that are using CFL lights or different lighting systems that can put off additional heat, the number of those fixtures are going to be important to understand when we talk about mechanical design, right? So all of these are important calculations to ensure that a design, when it comes before plan review or comes before a project for permitting, that we've evaluated, that someone out there is probably evaluating these systems, right? And that as things change, it may have an impact on the types and sizes of equipment that we're going to have. What we're going to be doing, and if we see here this example here, is sometimes that compliance path or that permit submittal will include or incorporate different types of res check. Well, we're talking about commercial projects, so we're going to incorporate that com check. This here is a screen grab from a com check that shows us that what we're looking for is that we're going to have a heating system for our convenience store that's going to be a single zone gas-fired duct furnace with a capacity of 130,000 BTUs per hour. So what that is going to allow me then to do is verify this information against my tables, right? I need to, this is, you know, it's sometimes it's easy to say, yes, this matches and this complies. You know, there's sometimes, especially with ComCheck, you can get that green bar and think that's the end of the world. That's the end of it all. We got the green bar. It's perfect. Well, we still need to, I believe in trust but verify, right? So we're going to go back and we're going to verify that these values match. And so we're going to make sure that this is, I'm going to compare that with my equipment schedule. Is this actually the correct unit associated with this material, with this BTU, with this this capacity of furnace? I don't know if we can see it up here, right there. All right, we've got the. I think that's the heating unit. I can't read it that far away. No, it's 150. So we're making sure that the equipment in our potential compliance documentation matches with what we're going to have in the building, and then we're going to compare that with our table, and we're going to find that this particular type of equipment, a warm air gas-fired furnace, comes under table 6.8.1-5, and then we're going to look at, based on the size, under 225 thousand BTU. This piece of equipment requires a minimum of 80% AFUE, right? And so we've got that 80% efficiency listed. So it matches. So this would meet those minimum expectations. Similar, if we take that second piece of equipment, that second element, that cooling element, we're looking at a single package DEX air-cooled air economizer system. We're going to look for that air-cooled air conditioner, that single DEX system, and we're going to find that same expectation, right? That we're expecting a 14.8, right? Because this is going to be a single package system. We're looking for that 14.8 because it's after 2023, and so they listed as a 14.0, but again, 15 still complies. It meets or exceeds that requirement. So again, this is where we start to really get into, is this equipment the appropriate size? One of those mandatory considerations is controls. We've got enough. We're going to try and run through some of these different controls today, but what we're looking at is, again, are we going to have controls in place that allow for control of the equipment, right? So the question is, they had to be heating or cooling, not both. So that's an interesting question, right? Some codes say, and I'd have to double check that one, Eugene, but my understanding from what's provided in the code is that it's a both, heating and cooling, right? We're talking heating and cooling. And that's one of those calculations that's very important to understand, because distinctions, prior codes said heating or, and then some of the newer codes say heating and. So it's very important to pay attention. And I think I'll double check and pull out the code section. I don't have it with me right here to confirm that for you, but that's the way it's been presented to me. Correct. So the code, and again, thank you, Artie, for making that point. So that's one of those conversations that we have sometimes in other outside groups. The code requires that you provide heating, but that if that, and so that's where you you have to provide heating. But when you have heat, and there is a push to include or incorporate into maybe the future, or if not this current code cycle that's being evaluated for 2027, by 2030, there's a big push to put in minimum cooling expectations within the code as well. At least there's a few proposals that are out there floating around. But yes, if the equipment is provided, it has to meet the load associated with it. But I would double check the actual language, because if it says heating and cooling, then interpretively, that's my interpretation, right? But I'm not the building official in your jurisdiction. It's the beautiful part about being in where I'm at. So again, we're going to have different thermostatic controls that control specific zones. We're going to have off-hour controls associated with different abilities and capabilities. We're going to have diagnostics associated with them, right? We're going to talk about how they incorporate ventilation shutdowns, shutoffs, dampers, and those kinds of considerations. Controls also that incorporate interlocks for humidification and dehumidification, that when we talk about larger spaces, right, there's going to be a variety of different controls. We're not going to run through all the controls, because that in and of itself is an hour-long, maybe more, conversation about when these different situations, when these different types of controls have to be employed. But there's the point that I want to provide here is that there is a variety of different expectations associated with those controls. Right? If we're talking about heated and cooled vestibules, we want to have controls there that recognize when that space is being utilized versus not utilized. I was in Amarillo recently, and and that's one of the things that, it's almost like when you're, any of us are probably, go around most buildings as a fire official. We walk around, we look for smoke detectors, we look for different things. I walked into a hotel and saw they had a secondary event area that had its own vestibule, and it had its own controls, right? Because it knows when it's being operated. We know the spacing, and then there's a lot of things that go into vestibules, which we could talk about for hours. Direct digital controls, economizer, when we talk about, again, fault detection, those types of things. Most important to the conversation is recognizing that those notes on what types of controls are being utilized on a particular project need to be incorporated. right? And a lot of times we see those in this section that of keyed notes, right? We see all the different list of different controls and diagnostic, distinctions to identify, right? That we want to make sure that these systems are tracking the right temperature in the right location to affect the right equipment, and that we're not having this interconnection. I had a building that I got called out to that was they had improperly wired a control with a heating unit to where it controlled the wrong room, right? It was office space, and so they had to go into opposing areas of the building to change the temperature back in the building. So it was one of those you gotta be kind of, obviously it's a control issue. We just need to recalibrate or resequence that situation. We've talked about again, one of the examples we might look at when we talk about it on actual plans was I had a building, a larger building. It was a police station, and one of the conversations with the number and of pieces of equipment that were in that building, we needed to have a proper sequencing of those controls so that we didn't have cooling equipment operating at the same time heating equipment for the same space, right? To where we're creating a potential humidification problem, right? So it's all about making sure that we evaluate the types of controls, the location of those controls, and the code provides us a huge section of code to dictate or to define, guide those conversations. When we think about some of the other mandatory expectations, again, is that distribution location. We start talking about installation expectations associated with the code. Again, remember, new technology, new materials means new ways of doing it. And again, we don't need to digress on that. There's going to be, again, the tables that exist on ducts and plenum insulation. Again, remember that was modified by the state, so it's a little bit different than what we saw in the actual 90.1. So you need to make sure that you pay attention, that you're making sure that they're using the appropriate size minimum insulation values. We see that with piping insulation associated with refrigerated lines, whether we're using that for, again, heating and cooling steam systems, right? We want to make sure that we're thinking about that pipe insulation. Remember, pipe insulation is not necessarily there to maintain the temperature as much as prevent from the chilling impacts or overheating impacts of the actual pipe itself, right? The 1 inch of or a ½ inch of insulation is not going to maintain the huge temperature swings. But what it is going to do is keep that pipe itself from cooling and overcooling over time, depending on its location. Again, when we think about heating systems, we talk about the expectation for radiant floor heating, so that again, we're not 3.5. R3.5 is not going to prohibit or significantly influence the amount of heat that goes, let's say, down in most situations. When we think about radiant floor heating, the intention with radiant floors is that we're heating the space above that floor. R3.5 is not going to prohibit or stop completely the movement of heat into those lower spaces, but it is going to provide a level of at least a basic level of resistance to moisture accumulation associated with those types of situations. So again, if we were looking at floor systems in a deeper dive, we could talk about, how much heat are you losing in a 3.5. That's, again, not the intention to prevent you from heating the floor or heating the space below, but it's to make sure that we're adequately shunting and redirecting that heat and preventing moisture accumulation. Again, we talk about air leakage expectations. We talk about the insulation associated with walk-in freezers, coolers, their freezer doors, the occupancy shutoff expectations, right? We need to think about time switches, motion sensors, anti-sweat heat controls. So again, we see this a lot more now than we did 20 years ago when we go into grocery stores, right? Where the cooling cabinets, refrigerated displays have those motion sensor lights that allow it to de-energize that lighting when there's nobody in the aisle looking at ice cream. I don't know how it's possible that the ice cream aisle is vacated long enough, but my family, we do our part to make sure that the lights are on in the ice cream section. But that may not always be the case. And so again, those lights don't need to be on if they're not providing a function. Same concept when it comes to the expectations associated with refrigerated spaces. The cooler cave at the local convenience store needs to have that may have, again, different expectations associated with insulation than what we see maybe in traditional refrigerated spaces. Talked about that one. So those are really those, remember, those are mandatory requirements, mandatory expectations for all compliance paths. And then we're going to have on top of that, depending on our different compliance path, maybe additional expectations associated with the prescriptive path, right? Or again, alternative compliance paths for computer rooms, right? We start talking about what makes a computer room, or an IT equipment, infotech equipment room. And so what are the expectations of those spaces, and how are they going to affect mechanical system designs, right? When we talk about air economizers, or again, when are they expected, and what is more importantly the impacts for controls and shutdowns associated with them, right? We want to make sure that when we're in climates 6 and 7, that if we're having cooling capacity over 54,000 BTU, that we're incorporating an economizer, right? And so a lot of times that's equipment selection that drives that conversation, right? It's all about understanding the design and what is that design calling for, and how is it going to mitigate outdoor air versus indoor air in that process, so that we're not, again, heating all of this indoor space, all this indoor air, and then shooting it outside to bring in more cold air. How are we going to use the economizer to get some of that latent heat out of it? Again, we're talking about zone controls that prohibit or prevent reheating, recooling, and mixing of supplying air, right? So again, if I have a large office, if I have a large, again, my example of a police department, the building has its own heating and cooling equipment, and then individual offices may have, in my example, we're being provided with mini split systems, so that what should happen is if a detective turns on the mini split, it should damper or deactivate or redirect the building-wide HVAC system, so that, again, I don't have one vent blowing down hot air and one blowing down cold air, right? So we have this understanding of zone controls, as well as we understand the influence that humidity can have on a building. I know Hope was up in Fergus Falls maybe last week. I think it was last week, and humidity seemed to be a little higher than maybe is normal. And so high humidity can affect how space is, the types of mechanical ventilation required to maintain comfortable building spaces, right? And so understanding that and having that awareness, or that ability to control for different types of humidity. Now, some things we can't correct for, right? If it goes 95% humidity, which is unseasonable, then there's no way to control for that. But it does need to be an evaluation based on our climate zones. So again, there's a variety of different expectations there. And I think and again, I'm seeing a lot of, again, and to Peter's point, I think, again, I'm seeing them a lot more simply because it's localized. And again, the project that I was working on was a 2-story police station where they had a huge radiator system for the building itself. They had a forced air system for the building itself, and then individual offices were provided mini splits. So again, it became a conversation about sequencing of equipment so that we didn't have units that operated independently, right? Without some level of interlocking or interconnection. So that again, if it's equipped with it, when the air temp, and if we read this example here, the units are equipped with an economizer control that when the outdoor air is at a temperature and humidity to provide free cooling, the damper will open to 100% to allow outdoor air to cool the space instead of the mechanical cooling equipment. We'll be equipped with a barometric relief to prevent the space from being overpressurized, right? That's the kind of level of awareness that we want in the building. Because if I can get free cooling and from a building based on the number of people in that building, based on what's going on, then again, that's the goal, right? We want to make sure that we provide buildings, that we don't create buildings that are so tight that we can't operate or occupy them, right? We've all had those people that have come into our office and said, we're building buildings so tight you have to poke a hole in it to ventilate. Well, yeah, that's because I want to control the air as much as possible. And if I can use free conditioning, then that's not a bad thing, right? But again, I want to make sure that I have those automatic controls in place that monitor that, because we also want to make sure that we're not creating a situation. It's one of those catch-22s. We can create systems that are so complicated that you need staff on site just to manage those digital controls and sequencings. So again, you have to have that overall approach, and the solution to a lot of problems is not just throw in something new, right? And again, I think the point that's made here is, again, the problem is getting fresh air with a mini split. So if the solution is not just, hey, I've got a problem with my air, let's just throw in a small mini split. Well, is that the solution, or is that a fit? Going to be more of a problem, right? I was at the a local restaurant that is in a shopping center as an tenant space, and they had a lot of moisture accumulation going on based on the cooking. It wasn't designed for that kind of space, and so their solution was, we'll throw in a mini split. They literally threw in a mini split on the wall, and it sucked out so much moisture that it literally it was pouring over buckets at times in their building, because they didn't take time to calculate the impact of the change of occupancy on that space. It was designed as a cell phone store and turned into a restaurant with open steam-based heating, or steam utilizing equipment, steam heating equipment. And so you just created more moisture and humidity in that space, and just throwing in a piece of equipment was not the solution, right? So again, part of that is understanding that and communicating that. And as building officials, my job is to make sure that we have safe buildings. And part of safe buildings means understanding that that throwing in pieces of equipment is not the solution every time, right? When we talk about maybe, and again, this is a longer conversation, but when we start talking about some of these different solutions that were being presented, they're not solutions, they're just different problems, right? We talked about it, I think, before, when we talked about surface water heating systems, right? If we want to change over, let me jump down to it. If we're jumping from if we think about surface water heating systems, right? If we're thinking about, we're going away from, we may have a current building that operates with a simple storage tank, hot water storage tank, right? And they're going to replace that with an on-demand instantaneous hot. Well, it sounds like a solution, right? We're going to be more water cautious. However, now we have to calculate into those what was the line sizes. What is the minimum sizing of our gas lines, right? Because we went from a 45,000 BTU water heater to a 190,000 BTU instant hot, right? It sounds like it's a reasonable solution. We're getting rid of a large piece of equipment, putting in a smaller piece of equipment, but really we're changing dynamically the expectations on the overall system, right? The same thing when we talk about mechanical design, right? When we think about some of the things that come into play, where we're moving beyond just simple replacement of equipment. And I think that's one of those reasons why it's important to understand when we put in new equipment, when we alter equipment, we cannot, as building officials, just allow for same and similar to rule the world. And again, that was one of those problems that we have where I'm at. I have HVAC companies come in all the time and would say, well, we're just replacing this unit with a same or similar unit. Well, no, what you're doing is you're putting it on the same size concrete pad, but it is not same or similar, right? It is not. It's going to have a higher demand on BTU consumption, on gas consumption. It's going to have a higher demand on the metering associated with the utilities that serve it. And so again, I need to know that all those calculations are being incorporated into that design, or that we're not creating a situation where, again, you've placed the diffuser for an HVAC system, right, in such a location that we're not getting that we're then going to trigger one of these pieces of equipment, one of these controls, right? So again, calculating their location, looking at their location, their designs is going to be that critical conversation. I need to move on, or else we'll never finish. Well, we're never going to finish anyhow. Again, some of the things that we think about are fan system power efficiency. We understand that there are tables, minimum or expectations for efficiency within those calculations, as well as standby controls. Hydronic systems, so when we're using water as a part of a boiler system or some type of comfort control device, that's a hydronic versus service water heating. Sometimes people get those confused, and I know you probably don't, but it's important to understand that hydronic controls or temperature controlling equipment is in Chapter 6, and when we talk about service water heating for actual fixtures, that's going to be in Chapter 7 of the Energy Code. And so again, we have the same tables on efficiency, heat rejection equipment, or HRV, ERV systems. Again, when do they have to be employed? More importantly, what are those expectations when it comes to their efficiencies are incorporated into the code? As well as, again, exhaust systems, right? What kind of airflow are we expecting to see, or limiting in the construction of different types of hoods, right? Those are conditions identified and expectations provided for in the Energy Code. Again, radiant heatings, whether that's, again, heating unenclosed spaces, loading docks, and those kind of things. One of the things that we've talked about, I was in a conversation a couple weeks ago talking about HVAC, radiant heating systems, and dynamic or digital controls, right? So that if I'm moving up, let's say I work down in, again, let's say I work in St. Paul, but I have a home up in Bemidji, and so I'm going to drive to Bemidji for the weekend. It's snowed. I want to have, there are going to be people that install digital dynamic controls so they can start that water heating system to melt the ice melt system for my driveway before I get there in 2 hours, 3 hours, right? So you're starting to see a lot more of that come into the play, and people are more. It's not that not as odd to see anymore. We talk about the door switches, which again apply to how we disable or reset heating and cooling temperatures based on whether or not those doors and openings are open for extended periods of time. Again, we see that a lot of times with loading spaces. We're not going to heat this entire space when there's a 16-foot hole door in the room. Again, I liken it back to my own personal home. When we talk about our French doors downstairs, if for some reason the kids are playing outside, we're leaving those doors open, then I'm turning off the air conditioner, because there's no point in paying for all this heat or cool when the doors are wide open. And exactly, I think you're right there. When we're talking about conditioned spaces, if we've got balconies in multifamily residential, then there needs to be a disconnect to where if I accidentally, and again, not intentionally, but again, if I accidentally leave that door open or leave that door ajar, we've all been in spaces that have been affected by uh, that situation, right? That scenario where you've left the door open and so the air has escaped. And so again, we're looking for spaces that allow for that type of door switch, right? So that again, how are we interlocking those systems? And again, refrigeration. Again, when we're using that, we're requiring that we're properly insulating this line and protecting against UV damage and other types of damage to the system. So that again, when we look at this equipment that's going to be provided for our convenience store, are we providing it with the appropriate protections, controls, and expectations? Now, we're not going to get, we don't have time, I apologize, to go through the entirety of what's required for surface water heating systems. But again, when we think about these compliance expectations, we're looking for controls, we're looking for equipment efficiency, we're looking for location, we're looking for sequencing, right? These are the expectations of what we want to see. And remember, there's flexibility in it, right? There's flexibility. And part of that flexibility is understanding what we're going to inspect and what we're expecting to see when we inspect. And sometimes we get a nice little com check, or we'll get an energy report that tells us what we should see as far as equipment efficiency expectations, duct insulation, locations, ceilings, ceiling details. Those again, controls and commissioning. Remember, the code requires that we identify those functional testing requirements so that we know from the beginning that there's going to be a knowledge or there's going to be a methodology for commissioning the equipment. We want to make sure that the equipment operates the way it was designed. I don't want to be responsible as a building official for a project that, we spend $200,000 on an HVAC system to find out it doesn't work, right? That's the kind of conversation that never goes well from the city or for the county, right? We allowed that to be there and it didn't work. So now it's all your fault. Why didn't you guys, what do we pay you for? What do we pay for that permit if you guys didn't look at anything, right? So again, make sure that we have the proper insulation. We look at those tables. Again, that we have heating, cooled vestibules. Vestibules are a fun one. There's some different things. We're going to have some frequently asked questions that have come up recently about vestibules. And so we'll be adding those to our website soon. But again, what are we expecting to see in those spaces as far as controls? Or maybe that water heater that's 119, gallons. Is that what's being installed, or are we going to go to a tankless system? Again, what are we expecting to see? And especially when we have those outdoor spaces, as many of us started to see, and some of us may have enjoyed during the COVID period, and now people are installing more of these timed exterior outdoor heating systems, making sure they have the appropriate controls in place so they're not running 24/7. When you leave, you're going to be asked to fill out a survey. Please feel free to put in some topics or let us know if there is a series that would be helpful. Again, we've talked about doing an inspection series, maybe doing every other week, talking about plan review, maybe some technical resources that we'll develop. We just want to make sure we provide you what you need. Here are some upcoming webinar topics. Again, we'll be looking at the lighting and power next week. Oh wait, mechanical plan review is not till November. Maybe we have to move that forward because I like mechanical plan review. Remember, we do have our next in-person training in North Mancota in the end of September on a Monday. So if you've not already registered, if you're interested, please let us know. We also have one up in Detroit Lakes in October, as well as a second one later on in October. If you have any questions, feel free to fill out our code helpline. I know we've got a couple outstanding questions that'll be out there. You should get your CEUs probably in the next hour. I'm going to move directly from this into CEU mode. So you should get those pretty quickly. Again, if you Make sure you have your DLI number in your registration, or that you put it into the survey. If you're also an architect, let us know your AIA number so we can report those as well. Like I said, I'm going to go into CEU mode here in a minute, but if you have any questions at any point, please let us know, and we'll get that to you. As far as the botched Zoom class, like we talked about, we will be doing that. I did re-record it, so I'll be sending you that video, and then those CEUs and certificates will all go out as well. So you'll be getting an email that says, here is the specific link to that class for those of you that participated. I re-recorded the entire thing just to make sure that you have a full document there. But again, if you want to watch some of our past webinars, they are online. So just go to our website, minnesotaenergysupport.org, and you can find out all you need to know about those. I see a question hands up. So Amber, you are unmuted. If you have a question, feel free to ask it, Amber. Dina, I appreciate that. You know, the technology is not always our friend, right? And so again, if you have any questions, feel free to reach out to us. If you're interested in hosting one of our in-person or hybrid training classes, please let us know. We will be in town a couple different times throughout the months coming up. And so, or be in the state, not in town. I say town, I mean the whole town, whole state. But again, if you have any questions, again, reach out to us. I appreciate your time. And you guys be careful, be safe, and we will see you hopefully soon.